The next node we're going to talk about adding is a very important one in time series forecasting, and that's called the lag feature node. But before we get into how to use the lag feature node, it's important to explain why this is a helpful node. And to set the stage here, it's important to simply know that all things being equal, the more columns, the more information you have, the better your model will perform in its predictions. During the learning process, every model has different ways of analyzing the data, but they'll always give attention to the different columns or features. In timestamp data like we have here, if we were to pick a column or a feature, like for example, total revenue, which we're trying to forecast, that aligns with that original date field, and we're trying to create more distinct columns aligning it to dates of the past, you're giving the model a better chance of picking up on that information. What I'm describing is creating a lag feature or a lagged column. For example, if you're dealing with daily data, creating a lag 1 column will essentially copy the total revenue values from the preceding row from the original date column and report it. Lag 30 would report on revenue from 30 days ago, etc. Again, it might not make a whole lot of sense as to why we do this, except to remember that this will help models analyze historical data better and give more accurate forecasts. Let's look at how we would do this. We have our downsample node here, which is the last node that we've added. And if we preview the data, we'll see that we have 4 columns: purchase date, region, which is what we're grouping our forecast by. And then for each month and region combination, we have number of units purchased and we have total revenue. But now we're going to create some lags so that we'll have a lot more columns, and that'll improve the performance of the model. So if we click plus here, or if we go to data prep up here and we start typing in lag feature, we do it like this. The prior node is the downsample node. The time series column is our purchase date. And then generally it's a good practice to lag all your numerical variables because, again, the more features or columns you have, the better the model will predict going forward. So in this case, we have number of units purchased and we have total revenue. So we're going to lag those 2 columns. And then our group column is going to be region, the same as it's been in our prior nodes, because we want to forecast revenue by region going forward. So we click save. And then if we click on this lag feature node that we just added and click preview, you'll see that instead of just 4 columns, now we have 30 columns. And as we scroll over, you'll notice that we've added these lag columns for number of units purchased as well as for revenue. You can see here for February 1st in region 1, the actual number of units purchased was 19, but the lag of 1, which would have been a month prior, is 14. And if you go over here, you see the lag of 1 is 14. And that's how lags work. We have lag 1, lag 2, and then all the way up to lag 24, so 24 months ago. And then we have the same thing for revenue. And now we have 30 columns to help us forecast revenue going forward instead of just 4 columns. And that's the beauty of the lag feature node. Now, when there are a couple models called DARTS models where you don't have to add this lag feature because the lags are specified in the model node itself. But for all other models, we do want to add this lag feature anytime we're doing a time series forecast. More on the DARTS models later, but for now, that is the lag feature.